Hello everyone, welcome to another video. In today's video, I will be deploying a web application, using various services in AWS. So this is going to be a complete hands-on project. So you will come to know how the different services work together to do what they're supposed to do. So as you can see in the diagram on the screen, so this is the architecture that we will try to deploy. So let's just understand what we are trying to do here. So what I'll be doing is within my AWS account, within an AWS region, I will have two availability zones, as you can see. I'll be using US East 1A and US East 1B availability zones, but you can use any two zones within an AWS region of your choice. Within that, I will have one VPC. So within my AWS region, I will have one VPC. I'll be using the default VPC, but you can use your own custom VPC as well. It's not going to make much difference. So within the two availability zones, I will have two subnets, one in each availability zone, as you can see, two public subnets, and also I'll be having one EC2 instance in each availability zone. The EC2 instances will be part of the AutoScaling group. The AutoScaling group will be attached to an application load balancer. The application load balancer is going to be internet facing, which means the users can connect to its DNS name via internet. So the users will access the main web application on the endpoint of the application load balancer. So this VPC that I'll be using has an internet gateway attached to it, so the traffic to internet and from user to the VPC is enabled using this internet gateway. Also, I'll be creating a dynamic scaling policy within our auto scaling group that is going to horizontally scale the number of EC2 instances, which is part of our auto scaling group. We'll be using CPU utilization as our metric to configure this scaling policy. This dynamic scaling policy is going to use a CloudWatch metric, CPU utilization. I've not spoken much about this Amazon CloudWatch service. And there's one more service, which is Amazon SNS, which I'll be using. So I'm going to have one detailed video on each of these services to make you understand all the things that are there. But in this video, I'm going to give you just enough information to understand how they work on a very high level so that we can use it in our AWS project. So I was talking about the scaling policy. So the dynamic scaling policy is going to use an Amazon CloudWatch metric, CPU utilization. The average CPU utilization of our entire auto scaling group. So what we'll be doing is we will be setting up this scaling policy as whenever average CPU utilization of our auto scaling group. So when I say average, I mean the CPU utilization of our entire auto scaling group. So in this architecture, we have two EC2 instances. So the CPU utilization will be the average of the two EC2 instance. So whenever this CPU utilization goes over 50%, then the auto scaling group is going to provision an additional EC2 instance to handle the additional user load. So this will be our dynamic scaling policy. So we'll be manually stressing our CPU on one of the EC2 instances so that the average CPU utilization of the auto scaling group goes over 50%, and the scaling event triggers as part of this dynamic scaling policy, and it's going to create an additional EC2 instance. So and also when this scaling event triggers, we will be receiving one email, or we can say we will be receiving one notification using another service called Amazon SNS. Okay, so SNS is another service. It's called a simple notification service, which is used to send emails to the users who subscribe to its topic. I'll be talking about this in a little bit. Okay, I just want to make you understand this entire architecture, that what we're trying to achieve here. Okay, so whenever this scaling event triggers, it's going to send a notification to SNS, and SNS is going to send the email to the user who has subscribed to its topic. Just remember this. I'll be coming to this this topic term in a bit. So this is what we are trying to achieve here as part of this AWS project. Also, all the work will be done via an IAM user. So we will not be using our root user email. So just remember that root user email is not a recommended way to do to create resources. It is only used for some specific purposes. Okay, else we'll always try to use an IAM user at least. So I'm going to create one IAM user. The IAM user will have administrator permissions within the AWS account. Okay, and then we're going to log in. We're going to log in with that IAM user and do and do all the things. Means I'm going to create all the resources using that IAM user. Okay. All right. So so that's what the project is. Okay. So let me come back to these two services. So to give you some introduction into what is Amazon CloudWatch and Amazon SNS. So yeah, so let's learn about Amazon SNS service. So SNS is a message delivery service. It's called a simple notification service. So what happens, the different services in AWS, they can send their messages of the events that happen within these services to an access point within this service. The access point within Amazon SNS is called a topic. Okay, so you create a topic within this service, then the other services which want to send their messages to this topic, they can send to it, and then what we can do is we can receive these messages via subscription policy. Okay, so these services publish their messages to an SNS topic, and then we as a user, okay, we can subscribe to the topic, which means if we have a valid email ID, we can subscribe to the topic so that we receive all the messages which are published to this SNS topic. Okay, so we become the subscriber, and this becomes the publisher. Okay, and then we are going to receive the email. I'm going to show this configuration also. Okay, so there will be a hands-on demo of this part that I just spoke about. So this is about SNS service on a very high level. Of course, I'm going to cover a lot of details in a detailed video which will be there on Amazon SNS in future. Then let's talk about Amazon CloudWatch service. So CloudWatch is a very popular service in AWS that is used to do a monitoring within your AWS account, which means that whatever services you are using, you can monitor the different logs, the different metrics, the different events that happen within these services using Amazon CloudWatch. Okay, metrics specifically, because CloudWatch has its logging feature as well, but here I'm talking about the metrics part, because we'll be using this CloudWatch metric to trigger our dynamic scaling event. Okay, so this CloudWatch can monitor the CPU utilization on our EC2 instances. It can monitor the disk usage on our EC2 instances. It can also do the network monitoring as well, and some other things. Okay, on a very high level, it is used to monitor the different metrics on the different resources within your AWS account. Okay, so so in case something goes wrong with one of your resources, so you can check the metrics on this CloudWatch, and then you can start troubleshooting it. So it is the monitoring service within the AWS account. Okay, the most popular service which is used to monitor your AWS resources. All right, so this is again this is on a very high level that I'm I'm telling you about this service. Once again, I'm going to have a detailed video on all the things that are there within this service in a future video. All right. So let's come back to our architecture, and let's just try to deploy this web application using this architecture. All right. So I'll be logging to my AWS account, which I've already done. The first thing is I want to create an IAM user with administrator IAM policy attached to it, so that I can perform all the tasks, okay, as an IAM user with admin access. So I'll be heading to IAM service. If you have any doubt related to IAM, I've already created one IAM deep dive video where I've spoken about all the concepts with a hands-on demo on IAM. The link of that video will be in the description of this video, so you can go and watch that. Okay, so we'll quickly go to users, and I'm going to create a user. Let's just write admin John, maybe. Okay, name of the user. And I want to give this user the access to AWS Management Console, because I mean we'll be doing all the things from the console. So I'll just select this option. Let's just use auto generate a password. Users must create a new password or at next sign in. I don't want that. I just want to use the auto generated password each time. So just click on next. Okay, admin Joy, maybe. Next, and attach policies directly. So I'm going to attach the policy directly to this user. So I'm going to attach administrator access policy here, which is an AWS managed policy, and I'm going to hit next. Once again, if you have any doubts related to this part, I've already created one IAM deep dive video, so you can go and watch that to clear all your doubts related to IAM service in AWS. Create user. So the user is created, and I can download these credentials. So this CSV file will have one console sign in URL, username, and the console password. So I can click on download. The file will be downloaded to your local computer. All right, now let's just copy this URL from here, and I'm going to log into an incognito window. So I'm trying to log in with the created IAM user now. Okay, so that I can avoid using the root user email ID. Okay, IAM user, I know it's admin Joy, and the password I can just copy from that same screen. Password, and log in here, sign in. All right, so as you can see, I'm logged in as admin Joy here. Okay, and I'm going to change the region from Europe, Stockholm, to Northern Virginia, that is US East 1. Okay, because I'm going to use US East 1A and US East 1B for this video, but you can choose any region of your choice. So whatever steps I'm following here, I've already created one GitHub repository for that, and it has all the details of each step that I'm trying to do here. So you can refer to that if you want to follow along. Okay, so it has everything. It has the steps. Okay, it has the aim of this video, and it also has the architectural diagram of our main web app configuration. It also has SNS and CloudWatch details. Okay, and also it has the default web application or the default ready to use website. Okay, so yeah, so I mean we'll be using this this website, which is there on this GitHub repo. All right, so I'm logged in as the IAM user. Now what I'm going to do is, let's follow the steps from here. Okay, so step 1, I've already created an IAM user, okay, with administrator access. The next is create a security group for a launch template and application load balancer. So once again, I have already created one detailed video on how to create a launch template and what does it actually mean, when to use it. Okay, and also I've created one video on application load balancer. Okay, so I'm not going to create these two resources. Okay, so I've done that already to save some time. If you have any doubts, you can reach out to me, or you can watch the video that I've already created on launch template, application load balancer, and auto scaling group. Okay, so there's a detailed video. There's a video which has all the details of these resources. Okay, I mean, when to use these resources, what does it actually mean, and how to do it. So those videos have the hands-on demo as well. Okay, I'm going to put the description of those videos in the description of this video, the URL of those videos in the description of this video. All right, so create a security group. Okay, I have already created one security group. Let me show you that. So if I go to EC2 here, let's go to security groups. And I've created one security group which I'll be using within my auto scaling group. This one, demo-sg. So this is the auto scaling group that I'll be using with my application load balancer as well as my auto scaling group EC2 instances. Okay, so here what I've allowed is, I've just allowed SSH secure shell, that is a port 22, because I want to log into these instances to perform, to manually increase the CPU utilization on these instances. So I've enabled port 22, and I've also enabled HTTP port 80 because I will be accessing a website that is hosted on the EC2 instances that are part of the auto scaling group. The auto scaling group is attached to the application load balancer. So we need port 80 to be allowed on public internet so that I can access the application load balancer's DNS to access the website. Okay, and outbound I've allowed everything, so you can use the same for this video. Okay, so this part is already done. Once again, if you have any doubts, please reach out to me, and whatever videos I've created in the past related to EC2, it has the details of all these things, how to get a security group, what does it mean, and other things. Okay, so you can go and watch that video. I'm going to put all the URLs of those videos in the description of this video. Next, so security group is done. Then I'm going to create a launch template. Okay, the launch template and auto scaling group. So once again, I've already created this launch template and auto scaling group. Let me show you that. So if I go to launch template and auto scaling group, I'm going to open it in a new window. So this is the auto scaling group, demo-lt, which I'll be using. Okay, and auto scaling group also. Let me just hit refresh. So this is the autoscaling group demo-asg, and this autoscaling group is already attached to our launch template, which is here. Okay, so it's already attached. So let's see what's next in the steps. So this is done. Now, well, what we'll be doing is we'll be creating an EC2 instance from launch template. Okay, so why would we do that? It's written in the next step, and that is point number 6. Sorry, point number 5, because we want to create a custom AMI Amazon machine image with web app configuration. Okay, so yeah. So what I'm trying to do here is, the concept is, I want to use an Amazon machine image, an AMI, which has the web app configuration already configured, because I will be creating the 2 instances as part of the auto scaling group. Okay, and using the dynamic scaling policy, I will be getting an additional EC2 instance. Okay, so the EC2 instance that I'll be getting should have the same configuration which I want to use with my other EC2 instances. Okay, so to achieve that, you should have the same AMI in all of your EC2 instances. Okay, so this auto scaling group, it uses the launch template to create the EC2 instance, right? The launch template has the AMI attached to it. Okay, that AMI, it can be an AWS provided AMI, or it can be your own custom AMI. So we'll be using a custom AMI which already has the web application configuration, so that we don't have to install this again and again. So this is how it happens in the real time also. You're not going to use the AWS given AMI in your real time projects. Okay, you will be getting your own AMI with all the configuration that you want. Then you'll be attaching it to the launch template. The launch template is already attached to the auto scaling group, right? So in this way, the auto scaling group can create the EC2 instances with exact same configuration with your already existing instances, because we are using your custom AMI that is attached to the launch template. So this is how it works. Okay, so I'm going to so this is what I want to show here. I want to cover each and every step that actually happens when you deploy a web application in AWS. Okay, but once again, this is on a very this is a very basic project. Of course, when you have very complex projects where you use this tool called you use some configuration management tool, or you use some IAC tool like Terraform. But here you should know how to create these things manually first. Only then you should move on to the IAC tool. Okay, so try to learn these things manually. So you should know how to create all the resources in sequence, and you should know how these things relate to each other. So that's why I've shown this architectural diagram here, so that you understand what we're trying to do here, what we are trying to achieve here. Okay, so try to do everything manually, and then if you want, you can do the same thing from an IAC tool like Terraform or Crossplane or some other IAC tool of your choice. Okay, all right, anyways, let's get back to where we were. So we already have this launch template and auto scaling group. Now I'm going to launch an EC2 instance from launch template, so that I can customize it, and then I can create one custom AMI and then attach it to my launch template again, so that it can be included with my auto scaling group configuration. All right, first things first. So I'll be heading to EC2 again, launch template. You can go to actions and launch instance from template. Okay, this is going to create one single EC2 instance. I'm going to use the default version, which is version 5 in my case. In your case, it may be version 1. That's fine, because I was doing some testing before this video, so I created multiple versions of this launch template. Okay, so I'm not going to change anything here. And so all the things are okay here in the launch template. So I just need to review it. So so once again, I mean, I've already covered this part, how you choose the key pair name, the subnet, or the security group, everything in my launch template and auto scaling group video. Okay, so you can go watch that video if you have any doubts related to any of these settings or fields. Okay, then everything is fine here, and I'm just going to hit launch instance. It's going to create an EC2 instance from the launch template. Okay, I missed out on something, so it says each network interface requires either a subnet or a network interface ID. Okay, let's go to edit instance configuration. Let's use US East 1A and launch instance. All right, the instance is created. So why it failed the first time? I did not choose the this subnet in which I want to launch my EC2 instance. So it gave me the error that please choose this subnet. So I chose the subnet and then hit run this create instance again, and I was able to create my EC2 instance. All right, so this is the instance. So let's log into this instance, connect, go to SSH client, copy this example command from here, and go to your MobaX term or any SSH client of your choice. I use MobaX term, and okay. Here, if you see this root as the username, please change it to EC2-user. One more thing, I'm using Amazon Linux operating system here. Okay, if you want, you can use other operating system as well. But if you want to follow along with each step that I'm following, so try to use Amazon Linux. Okay, so Amazon Linux has its default username as EC2-user. Okay, so I'll be logging into this instance, then I'll be configuring my web application, and then I'm going to create one AMI, which will be my customized AMI that I'll be attaching with the launch template. So let's become root. Okay, so what configuration I want for my this web application is, I want to install one web server. Okay, the most basic or the most simplest web server that you can use is Apache. Okay, so Apache, it's also called HTTPD. The name is HTTPD on Amazon Linux. So what I'll be doing is I'll be installing the this package. So yum install HTTPD space -y. So I've already installed it because I was already doing some testing. So it says the package is already installed. In your case, it's going to install the package. Okay, so after installing the package, what I'm going to do is I'm going to use a default website or a ready to use website, okay, to create my web server configuration. For that, what you can do is you can clone the same Git repository that I'm showing you here. I'm going to put the link of this GitHub repo in the description of this video so that you also can clone it. So code HTTPS, just copy the URL from here and just try to git clone. So I'll just see if I have Git already installed. Git is not installed, so first I have to install Git. So yum install git -y. It's going to install the Git tool. Okay, now I can clone the repository using git clone then the URL of the GitHub repo, like this. Done. If I do ls, I can see this web app ASGALB. So let's just go inside this. So you will see all the files here, index.html and other files. Okay, but what we have to do is let's come out of this folder. I'm using HTTPD or Apache web server. Okay, so the default directory where the content is served from this Apache web server is /var/www/html directory. So what I have to do is I have to copy this entire folder to /var/www/html folder. Okay, done that. If I go to this directory now, I can see this folder here. Okay, so all the things are copied inside this. All right, so now let's try to start the Apache web server. So I've just installed the web server. I haven't started it, right? I have to start the service also. So for that, I can use systemctl start httpd. Okay, then also I can enable it. It's important to enable it because on each restart of the instance, the service will stop itself. So you have to enable it so that it can restart itself automatically. Okay, you don't have to do anything. So enable the httpd, and now let's check the status. I'm going to put all these commands in the GitHub repo itself, so you can copy and paste from there also. Okay, done. The service is running and it has been enabled. So now let's try to access the website on the browser. How we can do that? Using the public IP address of this EC2 instance. So I have to go back to my management console and go to instance connect and copy the public IP from here and try to access it. Okay, so it's going to give you this warning. Since we are not using any SSL certificate, we are not using HTTPS in this video. We are only going to use HTTP. So just click on this continue to site, and then you can see a default website. Okay, so this is any website. I just downloaded this free sample website from internet. Okay, it can be any website. So that's not the main reason of this video. Okay, so it can be any website, but you can see it looks like a proper website. Okay, where you can search for hotels, restaurants. Okay, some places. Yeah, so this is the website that is running on my EC2 instance right now. Okay, I just configured it, so it's running absolutely fine. Okay, everything is okay. We have already installed HTTPD, the Apache web server. We have started it, we have enabled the service, and we have checked the service is running fine. The next step is to create the custom AMI. So let's go back to our steps mentioned. So we have launched an EC2 instance with the launch template. Now register a custom AMI with web app configuration. So for that, I'm going to go to my EC2 management console. Okay, to the instance part. Just click on this instance here, instance ID, then go to actions, go to image and templates, and then go to create image. This image means AMI, Amazon machine image. It's going to create the AMI with your current configuration. So whatever you have already configured on the EC2 instance, it's going to be saved in this AMI, which I'm going to create now. Okay, so let's name it as web app Apache. Okay, let's copy this here, reboot instance, it's okay, we can reboot the instance if in case it needs to do it. Add a tag, name, and paste the same value here, create image. Okay, the image is going to be created. It's going to take like 2-3 minutes to do so. You can check the status. So you just click on this AMI ID. And you can check its status. It's in pending status. Okay, in the meantime, what we can do is, AMI is getting created. So we are going to update our launch template with this new AMI. So let's go to launch template here. Click on launch template. So how we are going to update the AMI in this launch template? By creating a new version of it. So this launch template gives you the option to create multiple versions, okay, of your launch template. So what we have to do is, we have to go to actions and then choose this modified template, create new version. Click on it. And you can name it anything. So let's just copy the same name which we copied for the AMI name, Web App Apache. And then the next option is auto scaling guidance. If you want to use this launch template with auto scaling group, you can choose this option here. Okay, so let's choose this. Then source template, it's going to give you the default version which was already there in your template, which is version 5. Okay, so let it be. Then under this launch template contents, you have to change the AMI. So this is the most important part here. So this is what we want to do. We want to change the AMI from this AMI to the new AMI that we have created. Okay, so let's go back and see if the AMI is ready. This page, just hit refresh. Okay, it's going to take like one or two more minutes to complete. So from here you can just click on this browse more AMIs. Okay, so hey, as you can see, you get all the options. You get the option to choose an AMI given by AWS under this quick start AMI tab. You can choose the AMIs given by AWS, and whatever AMIs you create on your own, it's going to be under my AMIs. Okay, so the one that I am looking for is website Apache here. Okay, but just ensure that the creation of AMI is completed or not. Okay, so for that, just go back to this tab where you were trying to create AMI, hit refresh, and you can see it's available now. Okay, which means the AMI has been successfully created. Okay, so I can choose this web app -Apache from here. Choose this. Just wait for it to update. You can match the AMI ID also. So AMI ID is ending with 22C45. Now it's updated to 22C45, which means we have successfully updated our AMI within our launch template. Then all the other things are going to remain the same. Okay, we don't need to choose any subnet here because we are only creating the launch template version. We are not creating an actual EC2 instance. Okay, so in this case, we don't have to choose a subnet, but whenever we are trying to create an EC2 instance, you have to specify in which subnet you want to create a subnet, because the EC2 instance will have an IP address attached to it. Okay, so it is a mandatory field, but in case of this launch template version, it is not mandatory. So you can leave it as it is. Then everything is fine. Just hit create template version. Okay, so it's going to create another version. You can click on this launch template and see in this drop down of version, you will see another option called template 6. Okay, template version 6. Now the other thing that you have to do is you have to set this new template version as a default template version. For that, you can go to actions from here or from here, and you can set the default version of this template. So just click on this and choose the template version from 5 to 6, which is web app Apache is what we want, and then set as default version. So now the default template version is set to version 6, which is our new version which we just created with the new AMI also. Okay, so now this launch template has our new AMI configuration. Our new AMI has our web app configuration. Okay, now let's head back to AutoScaling group. Okay, the AutoScaling group I mean picks up the latest launch template version automatically, but just ensure that you are using the latest version or the version that you intend to use within your launch template. Okay, so just within this AutoScaling group dashboard, just click on this edit option here in the details, and here you will see which launch template version is this AutoScaling group is going to use to create any additional EC2 instances. Okay, as part of its scaling process. Still loading. Demo LT, and here just change from 5 to 6. So it is not refreshed yet, but if you refresh, it's going to change it to 6. But let's just choose 6 manually from here. So we just want to ensure that our AutoScaling group uses the latest AMI version or the latest launch template version. Okay, so we are going to use latest 6 and just hit update option here. Done. Next, so let's go back to our GitHub repo and see what's the next step. So update the register a custom AMI from with the web configuration, which we did. Update the launch template with new AMI, which we did. Perform ASG instance refresh. Now in the video where I covered the concepts around AutoScaling group, I covered AutoScaling group's feature of instance refresh, which means that whenever you update the AMI in your launch template, which is attached to the AutoScaling group, you want to apply that new launch template version to all of your instances within your AutoScaling group. For that, you have the option to perform instance refresh, which means that it's going to perform a rolling update of those changes within your AutoScaling group, which means if you have 2 EC2 instances and you want to update the AMI in each of those instances, it's going to do it one at a time. So one instance will be terminated, a new instance will be launched with the new configuration, then the other EC2 instance will be terminated, and the other EC2 instance will be launched with a new configuration. In this way, you are able to perform rolling update of these EC2 instances with the new configuration. So that's what we are going to do now. So go to AutoScaling group. Okay, since we don't have any instances at this moment, as you can see, I've set the scaling, the desired capacity, minimum and maximum capacity is set to 0. So I don't have any instances as of now. Okay, so in case you have your existing EC2 instances as part of the AutoScaling group, and after that you have changed the this launch template version, in that case you can go and perform the instance refresh. Okay, so it is not applicable in my case because I don't have any EC2 instances within my AutoScaling group right now. So what I'm going to do is I'm going to change the desired capacity and the minimum and maximum, because I want to have some EC2 instances here so that I can use it to deploy my web application, and then do dynamic scaling as well. Okay, so let's choose the desired capacity to 2, minimum to 2, and maximum to 3. So what it's going to do, it's going to create 2 instances for me, okay, with the newest configuration. Okay, this is because I have already changed the launch template version within my AutoScaling group. And now if I change this capacity from 0 to 2, it's going to create 2 new instances with the new configuration. So update. And it's going to take a minute or two to create 2 instances, because this is our desired capacity. Okay, so it's going to create 2 EC2 instances with the latest this launch template version. Okay, so you can go to instance management to check that. Okay, so it's in pending. Just hit refresh. Pending, in service. Okay, so the 2 EC2 instances are in service now. Now next is we have to create a target group and an application load balancer. Once again, I have already created one video, a detailed video on all the theory around the elastic load balancers. Okay, so you can go watch that video. Also, there's a hands-on demo of how to create an application load balancer. Step-by-step instructions are there. So I mean, you'll get to see how to create a target group and an application load balancer in that video. So okay, so I'm not going to do it in this video to save time. I've already done that just before the video. All right, so let's go to my EC2 console and see the load balancer. So from EC2, you can go to load balancing section and click on load balancers. And you can see the load balancer is already there. Okay. So this part is done. The next is we have to attach the application load balancer with our AutoScaling group. Okay, so what I'm going to do is I'm going to go back to my AutoScaling group. So let's go back to AutoScaling group. Okay, so when you choose your AutoScaling group within integrations new, you will see the option to attach the load balancer. Okay, so here just click on edit option here and you get the option to attach the load balancer. So you have to choose what type of load balancer you want to attach. I'm using an application load balancer. Okay, so you have to choose this option here, then choose the target group of the application load balancer, which is demo-lt in my case. So once again, I've already covered this in another video already, all the theoretical aspects, and that video also has a hands-on demo of how to create a target group and an application load balancer. Step-by-step instruction is there. I'm going to put the video of that. I'm going to put the URL of that video in the description of this video as well. Update. So what I did, I attached an existing application load balancer with my AutoScaling group. Now what I can do is I can go to the target group section of the application load balancer, where I can check the health status of the 2 EC2 instances which were there in my AutoScaling group, since I have attached it to this application load balancer. So that means application load balancer is going to perform health checks on those 2 EC2 instances as part of its health check process. Okay, so what you can do is you can go to target groups, which is this one, under this application load balancer section, under listeners and rules, click on this target group. It's going to open it in another window, and then you can check the status of the health check status of the 2 instances. So targets, 2 healthy, as you can see, 2 healthy, 2 healthy. Okay, so just one more thing I want to show you. In my load balancer, in the security part, I am using the same security group as I am using within my AutoScaling group. If you remember, in this security group, I allowed port 22 and port 80. Okay, and this is the same port on which I am performing the health checks also. As you can see here, under health checks, I am using the default port. Okay, the traffic port. Okay, so the traffic port in my listeners and rules is port 80. Okay, I'm using port 80 here. Okay, so So this is the port that I'm using, and this port I've already allowed in my security groups. Okay, because this is the same port on which the users will be accessing the application using the application load balancer's DNS name. Also, this is the application to perform health checks also. Okay, so that's why I'm able to see these two EC2 instances as healthy. Okay, just because of those health checks configured on port 80. I hope the concept is clear. If you have any doubts, please reach out to me in comment section. Okay, I'm going to answer all your queries. Okay, so this is fine. So now, as we can see, the two instances are in healthy status. What we can do is we can copy the DNS name of the application load balancer and see if we are able to view the website. Okay, so once again you will see this warning because we are not using any SSL certificate in this video. So we are not using HTTPS, we are only using HTTP port 80. Okay, so just click on continue to site and you should see the same site as we configured for our instance. Okay, when we were trying to customize the AMI, as you can see, so it's the same site. Okay, so now what happened, we created one EC2 instance from the launch template. We installed our web server on that. Okay, and then we created our AMI, attached it to the launch template. Okay, and then the launch template was attached to the AutoScaling group. Okay, we just updated the AutoScaling group's launch template version also, and then we created two EC2 instances. Since we created the EC2 instance after updating the launch, after updating the AutoScaling group, so those two EC2 instances got the same configuration from our customers, this customized AMI, which was part of the launch template. Okay, then we attached the application load balancer to the AutoScaling group. So since those two instances had this web server configuration there, so the application load balancer was able to perform successful health checks, and it was able to pass the traffic to these two EC2 instances since the health checks were passed for the EC2 instances. So we are using the same website on the two instances. Okay. So this is how the AutoScaling group works with an application load balancer. Okay, this is fine. Now then let's see what's next. Next is to create a dynamic scaling policy with a CloudWatch Alarm and simple notification service. So now what we're going to do is we are going to create a dynamic scaling policy within our AutoScaling group, and we are going to use one CloudWatch metric alarm for average CPU utilization of the AutoScaling group. Okay, so and then we are going to send the notification of the alarm to an email as well. Okay, so let's see how we can configure that. So just a moment. All right, so let's go to our AutoScaling group now, and under our AutoScaling group you can go to automatic scaling tab, and you can click on this option of creating the dynamic scaling policy. Okay, so here we are going to use simple scaling policy. So here in dynamic scaling policy section you have three types of policies. In this video I'm going to show you an example of simple scaling policy. Okay, so choose simple scaling policy. Policy name can be anything, so just use dynamic scaling Okay, and here you get the option to create a CloudWatch alarm. Okay, from here, so just click on this create a CloudWatch alarm. It's going to open in another window. Okay, so here you straight away get the option to choose the metric. Okay, so I want to use average CPU utilization. Okay, so what I'm going to do is I'm going to choose select metric. Then I get the option to choose what type of resource I want to use the metric from. So in my case, it's going to be EC2. Okay, choose EC2. Within EC2, I want to use AutoScaling group. Okay, so you get the option to choose the this per instance metrics also, but in my case, I want to use AutoScaling group. Okay, because I want to apply the scaling policy on AutoScaling group. So choose this. Then you get the option to choose the type of metric also. Okay, within your AutoScaling group, what do you want to use? I want to use average CPU utilization, which is here, CPU utilization. So just choose this. Also, you are I'm going to see the name of your AutoScaling group. In my case, it is demo-asg. So I want to use CPU utilization metric on my demo-asg AutoScaling group. So choose this. Then select metric. Okay, so the name of the metric will be CPU utilization. AutoScaling group is demo-asg. Static will be average. Okay, then a period, which means that for how much time this this metric should be hit, for how much time you want it. We want the alarm to trigger. So let's just keep it as minimum so that we can save some time. So let's keep it for 10 seconds. So which means that if every CPU utilization goes over 50 for 10 seconds, it's going to trigger the alarm, and the alarm is going to trigger the scaling event. Okay, the conditions is static. The value of the CPU utilization metric should be greater than, okay, should be greater than 50. Okay, so you can choose any value, but I'm choosing 50. Okay, then additional configuration, I don't think we have to do anything here. So let's just leave it as default and click on next. Then it's going to give us the option to choose the SNS topic. So here we are trying to configure when this alarm is triggered. So do you want to receive an email notification? It can be any notification, but in my case, it's going to be email notification. To do that, it's going to give me, it is giving me an option to create one SNS topic. This topic will be the access point of the messages. Okay, and then whosoever subscribes to that topic is going to receive the email from that topic. Okay, so here, so let's just try to create a new topic. And let's use the default name here. Okay, endpoint will be your email. Okay, in my case, I'm going to use my email. In your case, please use your email. So I'm going to use techapricate@gmail.com, and I'm going to create topic. Fine, and then I'm going to hit next. Okay, we don't need to choose any other option. Hit next. Alarm name, you can write CPU alarm. Okay, it can be any name. Just use any name of your choice. Hit next. Review everything and hit create alarm. So as soon as I chose my email ID there in the email ID section, I would have received one email. Okay, so let me show you that. So if I go here, techapricate, so I'm going to see an email from AWS SNS saying that do you want to subscribe to the to this SNS topic that you've just created? Okay, so you have to confirm this. So you have to confirm the subscription. So whatever messages will be sent to that particular SNS topic, it will be forwarded to your email after you confirm the subscription. So just click on this confirm subscription here. Okay, and you will get the message, the subscription confirmed. Okay, now whenever that alarm is triggered, I'm going to see one email from AWS SNS. Okay, this is fine. Done. And also if you want to check that, what you can do is you can go to SNS subscriptions from here, and you can see if your email subscription is confirmed or not. Okay, so there's only, as you can see, this subscription is confirmed. Okay, if you go to topics, you will see the topic that you just created. This is the topic. Okay, fine. This is done. Now let's see what next. Next, we are going to run CPU stress test on the autoscaling group and check if scaling event triggers. Now we're going to manually increase the average CPU utilization on one of our EC2 instances, part of the autoscaling group, to increase the average CPU utilization of the autoscaling group. So once it goes over 50, it's going to create a new instance. Okay, why it's going to create one additional instance? Let's see in the autoscaling group itself. If you go to okay, here we haven't chosen the action yet. So what we want to do is, so let's just hit refresh. We've created the CloudWatch alarm. Okay, now I can choose the alarm here, CPU alarm. Okay, so whenever this scaling policy triggers, I mean, what I want to do, I want to take the action as add, but you have the option to remove the instance as well, or you can choose a particular number of instances. So for that you can choose set to, but here I want to add. I want to add 1 capacity units. Okay, and second, allowing another scaling activity. So let's just keep this time to minimum. So let's just keep it as 10 seconds, or maybe keep it as 20 seconds and hit create. Okay, so here I'm choosing, whenever this alarm is triggered, I want to add 1 instance to my autoscaling group. Okay, and then I have to wait for 20 seconds for another scaling event to trigger. Okay, the meaning of this. So just hit create. So the scaling policy is created, as you can see here. Okay, so I mean, why the instance is going to, I mean, why so here, as you can see in the detail section, rather here, sorry, here in this section, so you can see the desired capacity is 2. Okay, we have 2 instances running. Okay, but the maximum capacity, as you can see here, is only 3. The maximum EC2 instances that can be part of this autoscaling group is set to 3, which means it cannot go over 3. So that is why I chose as 1 instance here. Just increase the number of instances by 1. If you want to increase the number of instances to other number like 5, 6, 7, any number, then you have to I mean, change the maximum capacity of your autoscaling group from here also. Okay, so here I've just chosen is at 3. So from 2 it can go up to 3. So that's why I chose it as 1. So from 2 just add 1 and make it 3 instances. Fine. So the next part is we have to run the CPU stress test. So how you can do that? So there's a Linux utility called stress that you can install on these EC2 instances. So once again, I'm using Amazon Linux. It works well on this. I'm not sure about other operating system types. Just try it if you want to install this on other operating systems, or if you can, please use Amazon Linux. It's going to work well. Okay, so to install this stress utility, you have to run this command. So let's just try to choose any one of the instances which is part of the autoscaling group. So let's go to instance management and choose this instance. So I'm going to SSH to this instance. Okay, and let's change the root to EC2-user and SSH to this machine. Okay, so once I'm inside this SSH, once I'm inside this EC2 instance, I'm going to install this test utility and then increase the CPU utilization of it manually, and then we'll see if the scaling event is triggered, if the CloudWatch alarm triggers, and if the scaling event uh, uh, is also triggered, and it's going to create one additional instance for us or not. All right, let's become root and let's try to copy the command from there. So to install, I think it's using the incorrect this one hyphen, so it should be this. Okay, so install this EPEL repository, then install the utility, done. Now what I'm going to do is I'm going to split this terminal. So what I'm going to do is I'm going to re-log in to this instance so that I have two instances of it, so that I can show you the CPU utilization increasing, okay, on the screen. So what I'm going to do is I'm going to copy this example command and I'm going to log into this EC2 instance once again, change it to EC2-user. Okay, so I'm almost logged in the terminal again. All right, let's become root. Now I'm going to split the screen. So split, let's use the horizontal split. Sorry, single. Okay. Okay, this is done. So so on the left hand side, I'm going to run this command called top command. It's going to show me the current CPU utilization on this machine. So let's just type top and then type shift P. So shift P is going to sort this, a list of processes by CPU utilization. So as you can see, current CPU utilization is pretty low. Okay, there are only some processes running, and it's not taking any CPU right now, only like 0.3 or 0.4. On the right hand side, I'm going to run the stress test. Okay, so I'm going to manually increase the CPU utilization on this machine. So for that, what I can do is go back to this and just copy this command as it is. Copy and run it here. So what it's going to do is it's going to stress the CPU, okay, the one CPU that is there on this machine, and it's going to do it for 800 seconds, and the process is going to run in the background. This ampersand symbol is to run this process in the background so that I have the terminal back and I can do other things. Okay. So now you will see the CPU utilization is going to increase, as you can see. So it has increased to 99.7 already. So almost, so all the CPU on this machine has been this utilized. So now let's head back to your AWS Management Console and see if the CloudWatch event triggers. So for that, you can go to alarms here, hit refresh. Okay, it takes some time to process the data, and then it's going to show the state as alarm, which means the alarm has triggered. Okay, so just wait a bit, need to have some patience here, and you will see this alarm is triggered because the CPU utilization has gone over 50%. Okay, or maybe because I've chosen one instance, so I've chosen one instance to be at 99.9, which means that 50 is the average CPU utilization across the auto-scaling group. So what we can do is, I can run the stress test on other EC2 instance also. So let's see if this works. So what I'll do is, I'm going to connect to the other instance as well. This is the other one. Okay, I think it just worked. Let's see. Okay, in alarm. Okay, it worked actually. We don't need to do anything on other instance. Okay, so I thought that I may have to log into other instance and run the test there also, but I think it just the average CPU utilization just went over 50 across the auto-scaling group. Okay, so it increased to that level that the alarm is triggered. So you can see the state as in alarm. Also, if you check the email, so you will see one notification also from AWS SNS. Okay, so CPU alarm is triggered, and you can see the details here. What does it have? It will show you are receiving this email because your alarm, CloudWatch alarm, has entered the alarm state. Okay, because the threshold has crossed. The threshold was 50%. The CPU utilization across the auto-scaling group went over 50%. Okay, so the alarm was triggered and you got the notification from SNS. Okay, threshold crossed. So this is how you receive the alerts also, the critical alerts. Okay, from AWS. So using SNS service. So the alarm is triggered. Now let's see if an additional EC2 instance was created within our auto-scaling group, which means that horizontal scaling is triggered. So let's go to our auto-scaling group, hit refresh, and you can see from 2, now we have 3 instances running, which means our scaling event triggered. Okay, scaling event triggered because we set it to whenever the average CPU utilization across the auto-scaling group, it goes over 50%, it's going to create a new instance. Okay, so now from 2 instances, we have 3 instances, right? In automatic scaling, you can check again. The policy was set to increase the EC2 instance units by 1 whenever the CPU utilization goes over 50%. So as you can see, we have been successful in doing this project. Okay, so we have 3 instances now. Is the scaling event triggered? Okay, so I just wanted to show you this in a demo. So now, right, so an application is still running using the application load balancers DNS, but now this is running on 3 instances instead of 2 instances. Okay, so the increased user load, or you can say whatever load on the application increased, the application load balancer is able to serve that. And if you go to target also, just hit refresh and you will see 3 targets now. Okay, so since the application load balancer is connected to our auto scaling group, so whatever EC2 instances are connected to our auto scaling group, it's going to be part of the application load balancer as well by default. And The application load balancer is going to perform health check on each instance within the autoscaling group, as you can see here. So the health check of the new instance also passed. Okay, so now the application is being served from 3 instances instead of 2 instances. Okay, so the performance of the application is going to increase. So this is how the autoscaling group is used to perform horizontal autoscaling with increased user load. I hope the concept was clear to you. Okay, so if you have any doubts related to any of the parts, any of the services here, please reach out to me in the comment section and I am going to answer all your queries. I hope guys this video was useful to you. Okay, and it can help you grow faster in your cloud journey, in your DevOps journey. Okay, all right, so that's all I wanted to cover in this video. If you liked it, please hit the like button. I request you to please share it with your friends and colleagues, and also please subscribe to my channel so that I stay motivated to create more content like this in the future. Alright guys, thank you, and I'm going to see you in the next one.